See its vertical and horizontal lines of 30,000, see the light cold for 19 weeks. The James Webb Space Telescope once again demonstrated its power. It is exploring the deepest secrets of the universe. It also provides spectacular images that allow us to see the structure of the universe in unprecedented detail. Although these galaxies are sometimes millions of light-years away from Earth, the Webb telescope's sharp images make them look like they are within reach. The first spectacular snapshot of today's video shows when observing stars with the help of technical means. Sometimes you can see some strange celestial bodies. For example, the faint telescope captured a luminous penguin and its bullet in the vast space. According to astronomers' explanations, the image is of a pair of galaxies located approximately 326 million light-years away. Numbered RPO 142. They continue to stage a complex gravitational dance. These two galaxies in Aquarius have merged for about 25 to 75 million years. This is our Milky Way and the Andromeda Galaxy, the fate to be faced in hundreds of millions of years. In the case of RPO 142, we are not dealing with a spiral galaxy, but an elliptical galaxy and an irregular galaxy. The latter is known for having no symmetry or clear structure. Irregular galaxy ENCT 936. Tidal wall formed by interaction with companion ENCT 937. Faint telescope's false color image in the near-infrared band. It looks like ENCT 936 is throwing cosmic colors around. Huge clouds of gas and dust are accompanied by a high rate of star formation. This greatly exceeds the star formation rate of our Milky Way. In our home galaxy, about 6 to 7 stars are born each year. But in the case of ENCT 936, up to 200 new stars are born each year. But in the irregular penguin galaxy, about to embrace this mainly composed of old stars, ellipses with significantly less dust and gas. But some patience is still needed. The distance between galaxy pairs, currently about 100,000 light-years, equivalent to the diameter of the Milky Way. Therefore, it will take hundreds of millions of years for these two structures to merge into a new galaxy world. The photo of the Book of Genesis itself is not new. The Hubble telescope actually captured this giant star foundry in 1995, 2007 and 2011. Other telescopes took more precise images. Then Hubble rephotographed this structure in the Eagle Nebula in 2015. About 7,000 light-years away from us. None of these images can compare to the images that Webb presented to the public in 2022. Our new eye in space reveals all aspects that were completely invisible in its predecessor images. Although the newly formed round stars appear as red spheres at the ends of the pillars, but the lava-like lines are actually just young stars. Rays that are regularly thrown into the surrounding cloud matter in their jane. Just that new combined map of Genesis published a few weeks ago shows us that we should never place Hubble images in a secondary position. Microblog's infrared data shows young stars and cool gas. And Hubble's images reveal unseen luminous hot gas portions in the stellar cradle. Our planetary system's king. The WEBO is known for tracking the most distant and oldest observable universe structures. It also observes the planetary realm around us from time to time. Through advanced observation techniques, we can appreciate the giants of our solar system from a new perspective. These images capture unprecedented details of Jupiter that optical telescopes and human eyes cannot perceive the details revealed by WEBO. To remove our natural blind spots, WEBO's near-infrared camera uses 3 different filters to capture the light reflected by this gas giant. In this way, infrared radiation in different wavelength ranges can be evaluated and displayed separately. However, since infrared radiation is invisible, the corresponding wavelength range is then converted into visible colors. Even the most experienced experts are impressed by the amazing details displayed in WEBO's images, including not only the well-known aurora borealis or the Great Red Spot, but also the subtle ring system that can usually only be glimpsed, and the small satellites Adrastea and Amalthea. In the solar system, Super Jupiter is the ultimate planet in our planetary system. with a diameter of at least 140,000 kilometers. Theoretically, our Earth could fit inside at least 1,300 times. But if we let our gaze wander beyond 12 light-years and take a closer look at the Epsilon Eridani system, some objects even make Jupiter look old. In detail, the exoplanet Epsilon Eridani b has 6 times the mass of the largest planet in the solar system. However, this unique alien world still holds a record. It is currently the coldest and oldest exoplanet observed using direct imaging techniques. So far, there are few directly imaged exoplanets. Most of them show young, hot gas giants that can be seen as relatively faint bright spots in infrared light. In addition, the approximately 25 exoplanets directly captured to date are all less than 500 million years old, most of which are even less than 100 million years old. The situation is very different with Epsilon Eridani b. It has actually existed for about 3.5 billion years. Researchers now hope to use it to test planetary evolution models and clarify unresolved issues related to the late stages of exoplanets, namely what is left after a star dies. Supernovae are undoubtedly one of the most powerful sights the universe has to offer. Once a massive star reaches the end of its life cycle and bids farewell to the cosmic stage in a violent explosion. Weibo images taken a few months ago in the constellation Cepheus show in detail what the debris field left behind after the star's death looks like. What we are dealing with here is a high-resolution near-infrared view of supernova remnant Cassiopeia A. It witnessed an event that occurred about 340 years ago. Due to the relatively close proximity of the stellar remnant to Earth, the structure of glowing gas and a central neutron star is one of the supernova remnants worth studying. While Cassiopeia has been previously examined by Hubble and Chandra X-ray observatories, Webb's near-infrared camera makes visible for the first time the details left behind by the explosive death of a star in 1680. The structure's inner shell oil slick is composed of lighter elements. Bright orange and light pink colors can be seen. We see again a white-like glow, which has a smoke-like structure, marking the place where the supernova shock wave entered the surrounding interstellar medium. Scientists believe the bright glow is due to light from synchrotron radiation, which is light from charged particles spiraling around magnetic field lines at extremely high speeds. If you like jade-like supernovas, it's dormant in the lower right corner of the image, named Baby Cassiopeia A. It may be a glowing dust field that was only captured and heated by the shock wave long after the star exploded. Although it looks like it's directly next to Cassiopeia A in the image, it's actually about 170 light-years away from the supernova remnant. The Flame Nebula has never been seen in such detail. Many shimmering family photos also bring exciting insights, while the James Webb Telescope recently revealed completely new details in the Flame Nebula, 1,300 light-years away. It also provides astronomers with a key clue to a special feature. Experts in this young stellar torso identified a group of so-called Herbig-Haro jets. These jets are emitted from newborn stars and interact with the surrounding gas and dust. These outflows point in different directions, but in this case, they all point in the same direction, from top left to bottom right. This fact in turn supports the argument of some researchers that very young stars tend to rotate in the same direction as they collapse in their gaseous birthplace. The reason why experts have only now detected this special detail of the Flame Nebula is simple. In previous images, the flame-like structure appeared as blurry spots, or was even completely invisible. Webb's high-resolution near-infrared camera is able to penetrate cosmic dust and gas clouds, making past optical obstacles a thing of the past.